I think tend to prefer. I do. It's certainly a lot less work. At any rate, just so you know who I am, for those of you that don't, my name is Jason Lee. I work for Oracle on the NetSuite side. That's my second stint with Oracle. Was bought with Sun and bought with NetSuite, so good times. But I am I'm a senior principal software engineer. That's my title. My role is that of architect, which is probably sounds more impressive than it really is. But we write. My group writes e-commerce software primarily in Java. We are starting a pilot on Kotlin, which is our topic today. So at any rate, as I said in the meeting invite, JetBrains, the makers of Kotlin, just had the inaugural, hopefully be more of them, KotlinConf in San Francisco, and with it they released a mobile app. If you've been to, well, Java 1 has it on other conferences, I'm sure, for managing your sessions and tracking things and rating. It had a little application along with it, so you knew where to go and that sort of thing. With the back end, it was all written in Kotlin, and I'm a big fan of seeing how the experts write stuff, because I've tinkered and poked on things, but if I can spend some time looking at how they did it, kind of get some ideas. So that's what I started doing, was kind of look at their application, and my initial inclination was to just take that, pull up the source, and start walking through things. But it was a little more complicated than I thought was probably easily digestible here, and certainly as I was trying to chase all the rabbits, it was a little more complex than I wanted. So what I've done is kind of taken their application structure and tried to strip it down to something that's a little maybe easier to understand. So what we'll look at is it's a backend written in Kotlin using the Ktor framework. I asked the JetBrains dev evangelist, how do you pronounce it? Is it Ktor? Is it Ktor? Is it something else? Like, well, he's I don't think he's Spanish, but he's living south of Madrid, and he's from some Europe. He's non-native speaker, so I asked him over Twitter, how do you pronounce this? And that conversation didn't go well, but I'm pretty sure it's Ktor, so that's what I'll be calling it. So Ktor on the back end, and we'll be using, take a real quick look at a library called Anko. It's a Kotlin-based DSL for building Android apps. So real quick, has anybody used Kotlin in anything? Okay, you've heard of Kotlin. Okay. From my last talk, yeah. I'm a big fan. It's I haven't gotten to use it as much as I'd like, but it's a cool language. How many have done Android development? Okay. Oh, excuse me. Well, that just hopefully won't dig much. So if you've done Android development, you know that there's a lot of XML, there's a lot of Java, a lot of boilerplate, and Anko does a great job of hiding a lot of that. They've got they developed a DSL for describing the views, and using Kotlin, it takes a lot of the boilerplate out. So we'll take a quick look at that. All right, so we'll just kind of start walking through that. We'll start on the back end. Ktor is I've got a. I do not. I know someone who works here though. Okay. Oh yeah. The internet needs to see me. Mm. Yeah. All right. There we go. I can zoom. I'm washed out. Okay. I don't tan, so. This is the GitHub repo, and it describes Ktor as it's a framework that doesn't impose a lot of constraints on what technology your project's going to use, logging, yada yada yada. So it's a minimalist framework that kind of lets you use what you want. And unfortunately, right now the documentation is also very minimalist. We've said for years, if you want to give a presentation on something, you don't have to be an expert, just pick something, talk on it. Well, that's what I'm doing here. It's a great vehicle for diving into this framework. So what I've had to do is kind of read what is available on the website, Ktor.io, and dig through the KotlinConf app and kind of make some guesses. So not the best way to go about it necessarily, but it was the only available. But it is very small, lightweight. Well, it wasn't the page I was hoping for. There's a couple of ways you can run it. You can embed Ktor in any Servlet 3 environment, or you can run it using Netty or Jetty if you want a smaller environment. But if you've got an application server, Tomcat, WebLogic, Glassfish, Pyre, or whatever, you can deploy a Ktor app to it pretty easily. You can run it standalone in more of a microservice-y type environment where you just create a fat jar or a Docker container or what have you and spin up your instance. We're going to use the Netty development engine. It's a little weird on the setup from the just so you'll see to run the back end. And this is documented on the website. We're going to run the development engine. Not super important, but if you grab the repository off Bitbucket, you'll need to know where to find that so you know how to run it. But this is the basic, not that. Here's the basic application. You can kind of see there's how you would run that at the embedded server using Netty. See if I can zoom that in. If we're on a Mac, I just control scroll, but I'm too cool for that, I guess. There we go. All right, so what we have here, it may not be immediately obvious here, but we have an extension function. Are you guys familiar with extension functions in Kotlin? An extension function, it's a compiler trick that allows us to add methods to an already existing class. So, if you need to create JSON or you want to add a split method to the string class, you can add a method using this syntax to java.lang.string and then just use that anywhere you want to. And behind the scenes, it creates a static class, and the compiler just knows how to dispatch to your method there. But we're basically adding a main method to the application class, which the framework is expecting that as our entry point, and I'll show you where that's configured here in a minute. The way the KotlinConf app is structured, we've got the application, we've got some routing stuff, and we've got a database class using a library called Squash. One of the great things about Kotlin is that the Java interop is awesome. In theory, you never have to use any special library. When someone says, hey, how do I write this in Kotlin? The answer is a lot of times, well, how do you write it in Java? You can just take what you know and run. However, with any new language, there are certain ways you can do things idiomatically. This is the way the language designers had envisioned things being written. So you can transition to that slowly over time. And the reason I called it Kotlin all the way down, if you're familiar with Greek mythology or whatever, what's holding up the world is a turtle, what's holding it up, it's a turtle, it's turtles all the way down. So what this application does is use mostly Kotlin libraries all the way down to the database. We'll see on the Android side we use Retrofit for the REST client, but everything we'll see here is I believe it's all Kotlin libraries, unless I missed one. So we'll take a look at the database class, which is going to use a product called Hickory for connection pooling, which is overkill for this, but it's kind of good to see it in production. And we're going to install a bunch of filters. Ktor comes with a bunch of filters or interceptors that will do a lot of stuff for you. Here we're adding default headers. And honestly, I'm not 100% sure what the default and conditional headers are. I copied that from the KotlinConf app, largely just show that you can do that. Compression, if you want to gzip stuff on the way out, call logging for logging the calls. Content negotiation, that'll help us as we return classes from our REST endpoints. We don't have to worry about JSON serialization. It'll handle all that for us. Going out and coming in, we just deal with objects and we let the framework do the heavy lifting for us. And that's how we register that for the content type JSON. We want to use the JSON converter, and we can kind of wire it in that way. And we want to pretty print it just to be kind to people using the say using curl, which we'll take a look at. The interesting thing here is routing. We're going to install the routing feature that is a class. The interesting thing here as well, what you see there looks kind of weird, but this is actually a function call. Install is a function that is going to take, I'll tell you what, if the IDE is not going to cooperate with me at the moment, but that is it's a function that takes two parameters. That's going to be a feature, and it's going to take another function to initialize that. One of the nice things about the the Kotlin compiler is that if the last method in the parameter is a function, you can pass it as a lambda using this syntax. You go and close the parentheses and just put it in curlies. So you see, it's a little nicer rather than trying to wrap that in the closing parentheses. Little syntax thing, but that's what's going on there if you're wondering what that syntax is. And the same thing here with get. We're going to pass the path parameter and a function for handling that request. Yes, sir?
Question about the scoping for get call. Is it bound to the routing first, like the routing library that you pass in the first argument, or how does that?
Get is a method on routing, and we're going to call the method on that route. So the routing instance will be the owning.
So on this callback, is this run then after the routing? You call this all the routing.
Get is actually not called just yet. Well,
but it's a callback, right? So it's called after the route is instantialized?
well, I guess it is called. This is the initialize function. So what we're doing here is we're installing the routing feature, and when it initializes that, it's going to call the get method on routing, which underneath calls create route from path, and it's going to register when you get a request for this path, call this function. So the function here, call.respond.text, we're not calling now, but the initialize will call that to set up all these routes. And we'll take a look here on API. I've got another, that's a method I've defined, that's an extension function. So we can take a look at API. And this is another extension function. We're adding the method API to the routing class. And this, of course, this is simpler than the KotlinConf, but they had several, sessions and speakers and ratings and things, and they broke that out into other methods so that you could take it in more bite-sized chunks. So here, this is a little overly complicated, but when we call the routing.api, we're going to configure our API, and we just have a single entity we're going to deal with items. I guess I should say what we're building here is a really simple, very dumb, just like a to-do list thing, kind of a semi-canonical hello world type thing. We'll display a list of to-do items and let you check it off. Not real exciting, but hopefully is significant enough to be helpful and small enough to be consumable. So we call routing.api. It's going to call this function, which then calls here, and we're going to create a route, items, will be kind of the top level, and we're going to define some verbs that we want to handle. So if we call items, if it's a get to items, we'll call this function. If it's a post, then we'll call this. Pretty straightforward. If you've worked with JAX-RS or some other REST frameworks, this should look fairly familiar. We've got a get, and we've got a path parameter here. So this will build on any path segments, to use a JAX-RS term, that have been defined above it. So this will be items /item ID, and since that is in the curly braces, when the request is dispatched to this function, it's going to take everything in those curlies, pull it out, and add it to the parameters object we see here, which we can then reference by name. Now, I'm not going to lie to you. This is a weird syntax. I'm not entirely sure what's going on there syntactically, but we're going to if the parameter ID is not null, then we're going to do this. Then we're going to okay. I believe what's going on there is this this little operator here is called the Elvis Operator. You know what it's called? Have you guys seen the Elvis Operator? If you kind of squint at it and turn your head sideways, it looks like Elvis. You got the two eyes and the little swoopy hair across the forehead. For the record, if you haven't, I think I covered it in my last Kotlin talk, but you know, there's a lot of null safe operators we'll take a look at, the question mark. But there's also, if you know something is not null and you're tired of being asked if it's null or not, you can do double exclamation. This may be null, but use it anyway. The name I've heard on the Twitters for that is the hold my beer operator. Like, I know what I'm doing, just make this call. It's pretty funny. So if called parameters item ID is null, then we want to return call.respond bad request. Otherwise, we're going to respond with a call to database.getItem. All right, so that's all we need to do here, really, to set up the routes. It's not a full-featured REST API. Clearly, we can get a list of items with the GET request. We can post to create an item here. We can get a specific item, and we can post to do an update. And if you want to argue if we should use post or put to update, we can talk after. For here, I just did post. All right, and that sets up the entire application. So if we run that now, well, I guess I should explain this. This is just kind of the just to show another way of setting stuff up. The example you go through, if you look at their homepage, is creating a blog. Why you would write a blog system in a library like this, I don't know. But if you just send a GET request to the root context, you'll get my example blog 3 type as HTML. We'll see that in a minute. We'll run it and kind of play with the API or with from curl. So the database, this is a little more interesting. We're going to persist things because that's what good applications do. We pass in the application. That's a Ktor object. io.ktor.application. We'll use that for pull and config. And this is a pretty typical Kotlin constructor. The class is database. I don't want to belabor language details too much, but not many of you have used Kotlin. So you notice we have no scope specifier on the class. One of the design goals of Kotlin was to reduce boilerplate. So JetBrains looked at all the Java they had written over the years and said, what causes us the most pain, and what do we find ourselves typing over and over and over? And one of the things they decided was that usually classes are public, and usually, I kind of quibble with this a little bit, but usually methods are public. So the default for methods and for classes is public. If you don't want them public, you mark them private. There's also a nice, if we have some time to dig into some of the actual the Ktor code, I don't know if we have any interest in that, but there's also an internal modifier. So if, in Java right now, pre-Java 9, if you have a method that you really don't want other people using, but it has to be public because some other class needs it, you don't really have a way of stopping someone else from using that. We saw that if you followed the JDK development with the unsafe class from sun.jdk or com.sun.jdk. Anyway, as an internal class, was never meant to be used, but it was public, and you know, if we see a public API, we're going to use it, right? Internal lets us avoid that. So if you mark something as internal, anything in that module, which is that basically be the Kotlin jar, can use that API. Anything outside that jar will not be able to. So it's a little lighter encapsulation than you might get with Java 9 modules, but that's a nice way of restricting access to your API. So just a brief deal on scope. All right, coroutines. Is anyone familiar with coroutines? Coroutines is a fairly new, well, I hate to say things are new. They've gotten a lot of press recently for concurrency. Threads are really expensive if you've done anything in application servers or highly concurrent applications. Multiple threads they're expensive, they're difficult to manage. So coroutine is an attempt to work around scalability issues without with minimizing the use of threads. And again, I'm not quite an expert on that, but using the suspend keyword there marks that as a coroutine. And through some funky low-level magic that I don't really understand, the system knows at certain points that it can suspend execution of a function or a call chain at a given point. And it saves all that in some sort of an internal state machine. So it might suspend this function and go run something over here, then come back and kind of rebuild that runtime environment and let the processing continue whenever it feels the time is appropriate without spinning up threads. So you can, where you might have, 1,000 threads or, I don't know, 1 million threads might swamp a machine. Using coroutines, you have, it depends on the implementation, but very, very few threads, and you can scale to just massive numbers of processes because it's very, very lightweight. So we're going to use coroutines in this, which will kind of help the application be a little more responsive. It can kind of suspend stuff, let the device handle another request or whatever it needs to do.
So is that only going to be effective if you have something that has a lot of I/O in it that it can suspend effectively?
Yes, the system will decide, a lot of times we'll see, thread.yield to signal that, hey, you can take time away from here. The runtime, again, through some deep, dark magic, kind of knows when it needs to spin this and run that and resume. All right, so Hickory is a connection pooling. So we're going to set up connection pooling for our very simple service. Notice we're using a fixed thread pool, which is kind of funny since we're talking coroutines, but we're going to set up a thread pool that our connection pool will use when kind of configure it. And we're going to use H2. So we don't have to set up an expensive database. And also, this looks a little weird here on line 51, but that is actually, we're constructing a new object there. Kotlin doesn't use the new keyword, which is kind of nice because it's really just kind of noise there on the code. If you want a class, you just class name, give it parentheses. This particular class takes, this constructor takes one method, which I'm not sure what its name is offhand. It takes a method that returns a connection. So we're going to pass it a lambda, and maybe that'll it will open the compiled code. Excellent. So what we see here is we have a public constructor. It's going to take a lambda that takes no parameters that returns a java.sql.connection. And since that is the last parameter in that method call, when we use it here, we can use this nice little syntax where we put the lambda outside the parens. And since there are no other parameters, we can drop the parens and just use the curlies. So nice, concise code. And then for connection.transaction, we want to create a transaction and run something inside that transaction. So this method is going to start a transaction on whatever database it has, run that body, and either commit or roll back. And that's all done inside this lambda. All right. And Squash is it's a library that again, it's developed by JetBrains. It's a very light ORM tool. with a JPA, Hibernate, or some of those, you've got annotations and a bunch of stuff. Very, very powerful and flexible, but very, very complex sometimes to set up. So Squash is just a very light ORM. We'll look at how we define the table in a minute, but what this is going to do is it's going to get a reference to the database schema, and we're going to create some tables. That's what this create method here does. And we need to pass it the tables to create. So what we do is we want to pass a list, and again, Kotlin has a lot of nice factory methods for creating a list, and we're going to call list of. And that it's a Kotlin SDK, Kotlin library method that's going to return an immutable list. Kotlin favors immutable over mutable, so you have to opt in to mutable state where you want it, because they looked at a lot of the errors they were seeing, and anytime you have concurrent applications, mutable state is almost always at the heart of your bugs, race conditions and weird things happening. So it encourages immutable development unless you really want it and they have ways to opt into it. So if you want a list that you can change, they have a method called mutable list of, mutable set of. I believe there's some hash methods that are the same. But that's going to create a list, and we're going to pass in the items object. The items is how we describe our table to Squash. And again, we see some new syntax here. Kotlin does not have statics. It doesn't really support, it supports singletons, but not in the sense that we usually see in Java. I mean, we might have a static instance of a class, perhaps in a getter, and you've got the initialize on demand holder pattern to make sure you really only have one instance of it. We kind of jump through a lot of hoops a lot of times to create a singleton. What this does, it's going to declare an object. The name is items, and we're going to extend table definition, and we're going to call its default constructor. It takes no parameters, but it is going to need initialization on that. So since we're defining a class, the curly here is going to define the body, and we're going to define a number of properties. So val, when declaring variables in Kotlin, you can use the val or the var keyword. Val is it's a value. It is an immutable property. You cannot change that value once it's set. The compiler will die. You might be able to use reflection if you really want to make an end run around security, but anytime you start using reflection, you're kind of asking for trouble. It's appropriate, but any harm you cause is your own darn fault, I guess. We're going to use some of the Squash functions to have a nice fluent DSL for defining the types. We want an integer, we want it named ID, we want it to auto increment, and we mark that as the primary key. All right, so there's our metadata for that property. We've got a description. It's going to be a varchar. It's called description, and we want a max length of 255. And completed, we want a Boolean called completed. Pretty simple, but when we call that database schema class, and that library looks at the definition of the class, it's going to see all of this stuff, and it can build the DDL appropriate for whatever database you're running under and create your tables for you. And that's all we have to do for the mapping. So that's pretty nice. All right. So we've set up our database, and now to actually do the work, we've got these functions here to notice. We've got the suspend keyword, so these are coroutines. And you can only call a suspend function from another suspend function, which is kind of weird. I can't just create this class and call get items. The library does support an entry point for that. The launch method is one of them. But it has to be done in a certain context so that the runtime knows, can manage the state machine for pausing and restarting those processes. So we're going to run this method. Well, technically, we're defining get items as a function whose body just calls the run method. It's going to run a coroutine using the dispatcher, and then that last parameter then again is the lambda for what we actually want to do. And again, we see connection.transaction, so we're going to start a transaction and do some work in there. And here we see how we can select. In this case, we just want to select everything. So we call items, the table, dot select, and execute. If you want to add filtering to it, see if I had a page open on Squash, but they've got filtering. You can add where clauses and all kinds of things to it through a nice fluent DSL. Seems to be pretty flexible. My issue a lot of times with a lot of those, the DSLs or HQL or JPQL, sometimes it's a little weird describing what you really want to do. You've got to break out to run just straight SQL, and it does have a mechanism for that if you do need to do that. Yes, sir. They're not callbacks, they're lambdas. These are not asynchronous to run, no. The get items function is a coroutine, so it can be suspended. I don't think it can suspend at an arbitrary point inside that method. So I think once control has been dispatched to this lambda, this function here, it will complete, but it may pause once it comes back out and do something else, is my understanding. So we select, we execute the query. That select method, you can chain a bunch of those, add your filters, whatever. Then we're going to execute it, and then when we get that response, we want to map that. So rather than getting a list or whatever back and then iterating over it, we can just do nice functional stuff and call the map method, in which case we're going to create a new instance of the item class, which is our actual, not items, item is our actual model, and we want to apply a lambda to it. So we want to set ID to the value of whatever it just returned from the database. You notice we use the word get. When you declare a lambda, you can list parameters and give them names. So if you've got 3 or 4 parameters, you would have parentheses here, and you'd have param 1, param 2, and you would declare, there we go, I was waiting for the red. You would declare your parameter names there. And Kotlin is really, really good about inferring the type. The compiler is going to look at how you defined your lambda and what function it's actually going to be delegating to, or what interface, or what have you, and it can kind of infer the type most of the time. It can't always do that, so sometimes you have to actually declare the type of parameter. But the apply method takes a lambda that takes 1 parameter, so we could give it a name if we wanted to. We could call it result if we wanted to. If there's just 1 parameter, you don't have to put in params. You can just give it a name, give it the arrow, and then the body of the lambda. In this case, though, since we're wanting to reduce boilerplate, what we can do is just leave the parameter name off completely, and the compiler will use the variable name it. So what we've done here is we've written a lambda that's going to take the lambda is the receiver method, and it's going to take what it's passing, that object, it, and call it.get and get ID. So we specify the type that we want it to return, so that kind of helps internally helps it dispatch the method we want. So we call the get method, we get the field ID, and return that as an integer value, and store that in the ID property on the item class. An item itself is really, it's a pretty stupid class. It's a dumb model. Again, notice it is public by default. We've got 3 variables, and that's it. And here we see kind of the other side of variable declaration, in that we want these to be mutable. right? We're going to create the class and set values, so we have to set them, or have to make that mutable. We could make a constructor where it was all kind of default, but we've not done that. So, but it's also a data class, and what that does is instructs the compiler that what I've got is just, it's a dumb model. There's not any logic to it. So what we get from that is we get equals, we get hash code, and we get toString for free. We don't have to do anything to it. It's going, the compiler, as it looks at that, it's going to create those methods based on the properties that we've defined. We have 3. We've got, and this is the syntax. I don't think that was clear earlier. We've got ID as an integer, and the default value is -1. Description, string, question mark. That question mark indicates that string is nullable. If I don't have that question mark there, and I try to assign null to it at any point, it's gonna complain like that. So the compiler will force you to give it a non-null value. The idea is, the early promise was that Kotlin would do away with null pointer exceptions. And that's it's not strictly true. You can still get them, but you've got to work to get it. So any of your Kotlin APIs, if you leave off that question mark, you know that stuff coming in, stuff coming out is non-null. You don't have to worry about it. It gets a little trickier when you start dealing with APIs from other languages, specifically Java or anything else running on the JVM. The compiler doesn't really know. We know that in Java, this method is going to return an actual value, but the Kotlin compiler doesn't understand that. So when you see it from a Kotlin perspective, it's going to have the question mark on it. It's going to be nullable, so you have to manage that. And we should see an example of that in a minute. But I've gone and marked that as nullable just for grins. I think from an application perspective, it doesn't make much sense to have a nullable string. And then the Boolean. Notice also we've got int is capital. In Java, we have int lowercase and integer. We've got primitives and wrappers. In Kotlin, everything is an object, so you don't have to worry about what to do there. The compiler, though, well, one of the reasons that Java has everything as an object, there's some backwards compatibility concerns and all that kind of thing, but there are some performance concerns early on. Object overhead can be pretty significant, especially when you're dealing with ints and floats and anything that's computationally intensive. So in Java, we have those primitive types. Kotlin has decided not to do that in terms of the language, but when it's compiled down, the compiler is smart enough to know that I can represent this as a primitive or as an object. If it's a non-nullable int, it will compile down to the primitive int. If it's nullable, it'll be an integer to handle that nullability. So that's our data class. Well, 2 things. Classes are final by default, so I cannot extend this class. They might have fixed this in Kotlin 1.2, but in 1.0 and 1.1, I believe, you could not extend a data class. So you can't have a hierarchy of models, which was a little frustrating. I think they either have or they've backed off that a little bit. So that's what's going on there. We're just creating a new instance of item, and we're calling apply, which is going to it's going to call this receiver function here, passing the value that we're mapping to that instance. And then we're going to return a list. It'll be a mutable list, which we can see the return type of the function there, and that'll return that to the client. Now, if I run this, and here's hoping, right? And it's going to rebuild, so, one of the complaints about Kotlin is that the compiler is not just super fast. It's just like the man turned into the newt. It's gotten better, but there's a good ways to go. You can see some logging here. Well, while that's coming up, let me show you the config for the application. We saw at the top of this, I kind of glossed over it, but application.environment.config, we can store all the config for the application in an external file. So at runtime, we can change things if we want. And that config file looks like this. It's a pretty simple one. We can specify the port, the applications. This really, that development engine, it's going to look, where's my main starting point, and this is how we bootstrap the class. We can configure the database. I'm not entirely sure what that property does, to be honest. I'm not chased that down. But that's the config, and you can change that at runtime when you're ready to deploy or in test, point it somewhere else. So now if we are running successfully and it looks like we are not, the file is locked. I've got it running somewhere else. Perhaps. And I have too many windows open. Such as Slack. My boss wants to talk. Don't tell him I ignored him. I'm looking at you guys. I'm running this in Android Studio, and I had a heck of a time getting things to actually run. I asked a guy for help, and he said, give me an example project, so I pointed to him Bitbucket, and a few hours later I had a pull request, and he fixed my Gradle build for me. It was fantastic. And I'd like to give him credit by name, but I can't remember his name offhand. All right, so our application is started. So if we go to the command line here, you can see I've been playing already a little bit. But we're going to send a curl request, and you guys can't see that very well, can you? Nine-point type. Whoa, that's not a whole lot better. Well, there's the curl request, and you can kind of see we get an array of objects back, and it's pre-printed. And yes, I'm running Windows, and I apologize for that. Don't hold it against me. Or do. I guess that's your call. But our application's running. I created an example object earlier. But you can see we've got an ID, we've got a description, and we've got the status on it. And if this ever actually responds...
Did you just make your prompt nothing?
Excuse me?
You just made the prompt nothing.
Oh. That is an excellent point. I think I was going to here, wait. All right, so that wasn't, but there's the GET request. You can kind of see we're going to request JSON, so it knows how to return it. But if we want to create an object, which you can't see just real clearly there. All right, so to create the object, we're going to post to the items collection again, specify a post, and we're going to specify a it's basically just JSON object. All we're given is the description. We're going to let the system set the ID, and we're going to default to not completed. So if we do that, it's going to return the object we just created. You see, we get the ID created for us, and there it is in the database. So all very fancy. All right, I think that is probably everything here. Yep. Any questions on that? It was kind of a whirlwind tour, and I'm not sure I have a lot of depth I can go into with it, but we can poke at something and make a random change if you'd like and see what blows up if you have anything. All right, well, let's take a look at the Android app. And I do have the emulator running, so at least I thought ahead on that. All right, so the Android app is also pretty simple, and this a lot of times most people's introduction to Kotlin seems to come through Android, because if you've written Android apps, which I actually really kind of enjoy, it's kind of a pain because there's a lot of XML involved, and There's just a lot of ceremony into building an Android app, which again has gotten better, but it's still pretty rough in spots. But Kotlin, just the language itself kind of helps reduce a lot of that pain. But the Anko DSL takes it even farther. If I were to, for example, let's create an activity. Let's create an. I hope I don't break my app doing this, but and of course I have Kotlin support enabled, so it's actually going to create the Kotlin class. And here's hoping I didn't crash the. All right. I don't want to add files to get right now. Thank you, though. All right, activity main 2. We'll look at the text. So we just created a layout with it's an app drawer or the drawer layout, and this is the XML we get. It's a lot of noise there, declaring XML namespaces and declaring IDs and things. And by default, they've been good enough to start using include, so we see the actual details here in app bar main 2. And we've got a coordinator layout, we've got the app bar layout, we've got a nested toolbar. We're going to include yet another layout, and we've got the floating action button there. And our actual content is here, and there's nothing in there. But that's a lot of XML, right? And our what we want to create really is it's a simple view with a list view. We don't need any real special noise. So the way we declare that is through that code right there. The Anko library defines a number of functions. It's also worth noting that in Kotlin you can declare top-level functions. In Java, if you've got a static method that you want to use somewhere, it has to be declared in a class. You declare it public, static, whatever, and then you can either import it statically or call class name dot method name. With Kotlin, we can define top-level functions anywhere we want to, and just call them as a function. Of course, under the hood, it does the right thing, creates the class and all that, but we don't have to worry about that as a Kotlin developer. We just declare the method and off we go. So that's what Anko does for the Android widgets. And here we're declaring a vertical layout. So we want all of our stuff to be displayed vertically in the view. We're declaring a toolbar. And I put Mist Player on there because I copied and pasted off of Stack Overflow last night when I was trying to figure something out, and it was late at night and I forgot to change it. But you can see we can set various properties there. We can set the ID, we can set the elevation on it, give it a title. We can set parameters on that. We want that to match the parent so that when this toolbar shows up, it's going to fill the width of the parent. Then we create a list view. We set the adapter value on that. And again, we set the width and height on it so that the list view is displayed correctly. And that's all we have to do. I don't have anything as complex as what we just saw with all those multiple files, but rather than XML and all the namespaces and things, we have a nice, concise DSL to declare things. If I wanted to add a button on top of that, I could just say button. And again, the method's going to take some sort of initializer method, and that's what this lambda is. I've not used the button before, so it complains. So I just tell it to import the type, and we've got that method now available to us. And what is it? Text. Hopefully I have that right. All right, and I added a button there. Super simple. The downside to this is that Android Studio really does have a pretty nice visual designer. There's not much on this UI, so there's not really much to show. But if you're using XML, and you've got this nice visual design there with little guidelines. Well, there we go. And you can kind of see, click on UI elements and see where that shows up and set properties. So you have a nice editor. You kind of lose that when using the Anko DSL, but you can kind of choose how you want to go about that. Certainly for simple views and in my somewhat limited experience, this is pretty awesome. All right, so the class itself, again, I followed the KotlinConf pattern on this, where we have the view defined, we've got a data repository. Shouldn't be too terribly unfamiliar for people coming from a Spring background. I've always called it a DAO or service layer. It's just another term, but we've got this data repository that's going to hold all of our data logic, and that's where we'll actually make our REST calls. We've got an adapter. I named this app Kotlist because I'm terrible at naming things, and it seemed nice and punny. We're making a to-do list management app in Kotlin, so that's what that name means. You can hate me later, I guess. And here we'll see, also idea, no drag and drop. All right, we declare the variable adapter as nullable. I want to take the M off there because that drives me nuts. All right, so adapter is of type Kotlist adapter. It is nullable because it's not created when we create the class, so it has to be nullable. We can't create it in the constructor because there are certain parts of the application that have to be up and running before we can actually create the adapter. So then here in our code, we have where we actually create that. And the adapter takes the context and a list of items that it wants to display, and we're going to default to an empty list, which I could have defaulted in the class declaration if I wanted to, but that's what that list of there, just an immutable empty list of items. And here we see that it's nullable, but I know it's not null because I just created it. And if we get to line 34 with adapter null, well, there's no way to. I mean, if we get to line 34, we're guaranteed to have it not null. So I don't want to have to do null checks. Now, Kotlin does have, like I said, pretty nice null handling. If I wanted to, I could say adapter, do question mark, and it's the null safe operator. So it's not going to do anything to that variable past that if it's null. Question mark dot method. If adapter is null, it's not going to call it, which is pretty awesome. But we want to do some work with adapter, so what we could do, there's, again, an extension function called let. So we can say, we can do that. Now, if adapter is not null, then it's going to run that lambda using adapter. In theory, though, the compiler knows that we've just done this check, that it's not null. So in this lambda, adapter is not null, right? The problem being that in a multi-threaded environment, we can't tell if, or we don't know between that let and the start of the function, if our thread was suspended, something else happened, and the value of adapter was changed. So even inside that let block, it's a mutable property, could be null, we've got to do another check. I'm not sure, well, that'll work. If it's not null, go ahead and make the assignment. Of course, I'm assigning it null there, just for granted. So we can define it that way and even not do that, or we can use the hilariously named hold my beer operator and say, I know what I'm doing, make this method call. And what we're doing here is setting the on-click handler. Kotlin does, again, stripping out some of the ceremony. If you have getters and setters in your Java class, you don't have to call get or set. You just say object.property and assign it the value, item.id equals whatever, and it's going to call set ID, or foo equals item ID, and it'll call get ID for you. So you don't have to call get or set, the compiler does that for you. So your code's a little more concise. So what we're doing here is calling the set handle click method that we'll look at in just 1 second, and we're going to pass it a function, and we're using a method reference for process click, which is this method down here. So when someone clicks on an item in our adapter, we're going to call this method on our activity. All right, and we'll look at the repository in just one moment. But the repository is also full of coroutines. Remember, I said you can't run a coroutine except from another coroutine. So here's our entry point to that coroutine area. Launch, we pass it a lambda, and it's going to call repository.updateItem. But real quick, just looking at the Kotlin adapter, this is something that I wrote. All right, and this is just a typical adapter. If you've done Android development with lists, you've seen this before. And basically, we're telling the system, you've got a list of some type. Here's how you create the view to show in the list. And really, all we want is a checkbox and the description of the item. So we've got the handle click method here. It's a var, so it's settable. It's going to take a function that takes one parameter. We've called it item. It is of type item, and it returns unit. In Java, if you return nothing, you return void. In Kotlin, it's called unit. Don't ask me why. That's just the way it is. And this right here is actually the type for the variable handle click. The type of that variable is a function with those parameters. And it is nullable because we don't have anything by default. So we set the question mark and initialize to null. You cannot leave that off. Kotlin will make you initialize every variable, whether it's nullable or not. In Java, that's an object, so it would automatically be null. Just the way the class is constructed, Kotlin will make you specify that explicitly, which is a little weird because they're wanting to cut down on a lot of the ceremony and the noise, but instead they add explicit initialization. I guess the upside of that is it's clear exactly what you're getting, but it seemed pretty clear to me. Ints are zeros, integers are null, but whatever. So that's what's going on there. And we're going to override the getView function or method on the array adapter class. Notice, since we are overriding a function, we have to specify override. If I leave that off, it'll complain. Again, they're adding stuff to it, but the idea there is that we want to be explicit about when we're overriding things so we don't accidentally hide methods. I guess in their research they found that happened quite a bit. Someone would declare a function, hide something from the parent class, and things behave kind of oddly. And again, we're dealing with Java API, so you notice that when we override that, these variables are, we don't know if they're nullable or not, so it defaults to being nullable. So we've got a function called getView, takes these three parameters, returns a view. We're going to pull the item that we're looking for out of the list, which really we're just storing internally on an array. And then with parent, and we know parent's not null, and we just know that from the guarantees the Android platform makes for us that parent will not be null when we call that. So with parent.context, we're going to run this lambda. And again, here we use the Anko DSL to declare what that lambda looks like. We want a linear layout. We want that to be horizontal, so it's going to go across. We've got a checkbox. Its isChecked property is initialized to the completed value on the item. We're going to set an onClick. Notice we declare a variable name there, but we don't actually use it. So the compiler is nice enough to tell us, or the editor, that it's never used and could be renamed to underscore if we wanted to. If you have a lot of parameters you're not going to use in your lambda, you don't want to give it a name, just cut down the noise, you can call it underscore, and it'll be just as happy. So in our onClick, we're going to update our model to reflect the state of the actual UI element. We're going to get the isChecked value of the checkbox, set that on completed, and then we're going to call handle click. And remember, handle click is nullable. and we don't want to do anything if we haven't defined a method on that. So we use the question mark, the null safe operator, and call the .invoke. Since that's a function, we can call the invoke method on that function to actually call that in a null safe manner, and we pass it the item. So when we click on that in the UI, it's going to come to this onClick method here, and then call our the method on the outside. And text description, or text view is the description. We'll set the text size to 16. There's probably some more device-independent ways of doing that, but 16-point font on that. And these other methods are really just for pulling items out of the list, kind of helpers for the get view here. Update items when we call, if we, and I didn't actually implement this, but if we have a refresh button and we hit the REST API and get a fresh list of items back, we can use this to set the items on the, actually we do call this, excuse me, we call this method to set the updated list of items on the adapter. Then we call notify dataset change that tells Android, my data's changed, you need to redraw yourself. Otherwise, we'll never actually see it in the UI. All right. Our API, we're going to call REST to hit the back end, so we're going to use Retrofit 2. If you've ever seen that, it's a nice, we declare an interface and use some annotations. It's going to generate the code for us, which is pretty kind of awesome. So we're going to call get items and post items. So in this, all we're going to do is get a list of items and update a single item. But we say we're going to make a get request to this endpoint. Get all is a method that we'll call in our code, and it's going to return a list of items. And for post, kind of the same way. We've got a companion object. If you have something that you want static in a class, like I said, Kotlin doesn't have static methods, static variables. So if you want something that's static, it's the equivalent of Java statics, you declare a companion object. And these are going to be properties on the class that will be shared across all instances. So it's effectively like a static method, except it's not. So, just kind of syntactic sugar on that. So we're going to call a create method. This will be our way of getting an instance of the Retrofit API, and we're going to use the JSON builder so that we can deal with JSON. We're going to use the OK HTTP client for the actual REST work. And then we use the Retrofit builder, past our client, the endpoint, and everything. And we tell it to return a list of that, or an instance of that interface. And it'll synthesize that Java class for us and return that to our Kotlin code. And one last, we're running short on the repository. This pretty simple class. Again, this I think is a little more complicated than we really need for this app, but I just went and followed the pattern again from the KotlinConf app. We've got a variable in there for storing internally. They had a lot of data. They would make one call when it started, get all the data back and store it internally. So that's an option. And here we have a private immutable variable called Kotlist API, and that's our reference to the to our REST client basically. And we have an initializer method on that. It's lazy, so it means this object is not going to be created until someone actually asks for it. So if you've got something that's expensive, that is large, takes up a lot of memory, you can declare a lazy init like this, and it won't be created until the first time it's used. And then after that, it'll store that, and you get the same instance every time. But you can defer any sort of expensive or memory-intensive operation until it's needed. Have an on-error method. Again, this is just it's a callback method. It's a method that takes an error object, returns a unit. For updating the item, here we can kind of see how we're interacting with our API. We're going to pass in the item we want to update. I make a copy of that because the item parameter is immutable. It's a val. So we make a copy of it. We call Kotlist update item, and we call await result. In this case, we want to wait till our REST response returns. You can probably do that in a little more asynchronous fashion with the callback, but in this case, it's super fast, we're just going to wait for it. If it's succeeded, then we want to call this method, and the payload for that parameter is going to be the response from the REST endpoint. And the update item object, kind of hard to see that because it's so tiny, but it returns, it's wrapped in a call, but we're returning an item from our endpoint. So from our repository, we're going to get that unwrapped object. So response is the type item, and we assign that to result. The reason we're doing that is somewhat for, for uniformity. If you're creating a new item, you don't know what the ID is, but once you've created it, you'd probably really like to know. So if we were to implement a button to add an item, we would post to the collection, we'd get that back, and then the response object would have that ID, so we assign that to a mutable local variable and return that from the function. Here on if error, if error and if failed, I actually used it here. If on error is defined, then we want to invoke the method, return failed to get data, and we can, in our application, display a snack bar or a toast or whatever you might want to do, or just log it and move on. But that allows us to interact, to intercept that if there is an error. And that's all we have to do right there to make that REST call. Using Retrofit, we don't have to do a lot of handwritten code. We can just define the interface that kind of matches what we know about our remote service, and just call the interface there. Now to see that running, go and make sure it recompiles. I didn't put a lot of work into this. Don't go home and try to manage your to-do list with this. I don't have a refresh button or an add, so it didn't seem like there was a lot of value in going through all that. Just more code to look at. And again, this is Android and Kotlin together, so it's really slow. Yes, sir?
Just a question about is all the code formatting standard? Like I know Go kind of forces you to format a certain way. Is there like a built-in formatter?
That's just the default Kotlin style from Android Studio. So yeah, you can change it. It's not white space sensitive at all.
Well, I didn't know white space is it, but I just learned.
Oh no, you can do all that all in one line if you really wanted to. I wouldn't, but while that's running, Android Studio does have an instant run. There's a little button here that you can click that, and it'll deploy the change classes. Right now, it's running the whole build process where it's building the APK, it's running the Dexer and all that. It's kind of obnoxious. So I probably chose pretty poorly when I clicked that run button. And we'll start here in a minute. Hopefully. Oh, installing APKs, we're close. Don't give up yet. There we go. And see, there's a little instant run detected. See, I added a button to it and it confused my view. So let's come back over here. I didn't set the parameters on it. Let's remove that view. We're going to save it. Click instant run. That was all a very long and clever ploy to show off instant run. And I think they oversold it a little bit with instant run. While we're waiting, any questions? Any way you'd like to break the app?
Uses Kotlin for backend stuff, so it's pretty common in Android, like what you're showing.
It's kind of hard to say. The numbers on GitHub show a huge increase in Kotlin, but that's probably mostly Android related. Like I said, JetBrains though does use Kotlin a lot. Well, isn't that fun? They use it a lot in their internal apps. Was it UTrack and I'm drawing a blank on their apps, but they certainly used a lot, and you know, if you go look and you can see a lot of companies talking about their use of Kotlin in non-Android environments. You know, it's hard to say with any real specificity on that, but it's certainly gaining. Well, it did not hit my endpoint. See, that's what you get for doing live demos. Let me close some of this stuff here. Make sure I'm pointing to the right. 8180. Yep, that ought to be working, because there's data. How weird. Let's look at Logcat. Logcat's your friend. And it is not today. Well, it was working. I'm just going to wave my hand here and assure you it was working. So I'm not real sure. Like I said, I ran it at the office before I came over, so I don't know if I dinking with it here. But what we would see here, real simple, kind of a boring interface. It's a checklist. You click a button, and then we would see it change on the back end through curl. But and that's really the last part of it. So. But like I said, you know, it is gaining popularity. We're looking at it. I hope I don't get in trouble for saying this, but we're starting to pilot at Oracle NetSuite to look at introducing Kotlin into our backend. It's primarily Java, a little bit of Scala, and we've got a pilot in the next release to see how it goes. And if it goes well, we'll have a little freer hand for one more release to try Kotlin, and then it's going to throw open the barn doors and let people go nuts with it.
Where are you choosing to kind of pilot that or get run servlets in it? And Kotlin and then integrate with the rest of your
They haven't really picked a spot for it yet. Our application is a very old one, isn't it, Robert? Yeah, it's a very old application, a very large. And we are technically servlet based, but we don't use JPA or anything. So I mean, it's a lot of proprietary in-house stuff. So we'll find somewhere sort of off to the side to implement business logic, and if the actual network servlet level stuff is already, we're not touching that. But we'll find something, implement some application feature in it that's not super critical. So if things go sideways, we can actually ship the product without that feature. But it is in a web app environment. So, any other questions? I broke the actual Android app, so there's not much left to break there. But if there's any other APIs you'd like to dig into, we can. No? All right. Well, thank you all for coming. We're right at 12:45, so that's perfect.